Hi you guys, today I'm going to talk to you about stoichiometry. For this lecture you'll need your notes, a periodic table, your calculator, and a pencil and highlighter. Okay, let's get started. Stoichiometry is the process of using a balanced chemical equation to solve for quantities of chemicals. This process is based on mole, okay, and is often done with dimensional analysis. So you will be using dimensional analysis to do this. The steps to stoichiometry is first you always write a balanced chemical equation. Then you calculate for the number of moles of the given substance. And that's the key. This is for the given substance. You use the coefficient from the balanced equation to find the moles of the desired substance. So this is where your mole to mole ratio comes in, where you're using to go from one substance to the other, which is your desired substance. Okay. And fourth, you determine the requested quantity for the desired substance. Usually, you'll ask for mass, but volume or a number of molecules can also be used. So we usually do ask for mass, but other things can be calculated for. Okay, so this is usually your dimensional analysis setup for stoichiometry. You use the very first, you start off with what is given to you. And if you start off with the number of grams of, let's say, substance X, then of course you would use the atomic mass of substance X. And of course the atomic mass is equal to 1 mole of that substance. Now this is where you're going to use your coefficient, okay? This is where your mole to mole comes in, your mole to mole ratio, okay? So this is where it's going to come in. So you're going to start off, your given is going to be written in the denominator, and whatever desired substance or your whatever value you are trying to find, the coefficient or the mole will be written on top. Then 1 mole of your new substance will be at the bottom because you're trying to cancel. Remember, this will be mole, the unit, okay? And it'll be a number value, your coefficient, okay? So this will be 1 mole of that new substance, and then the atomic mass of that new substance will go on the top. Then right here, we are just basically converting to whatever special unit we have. So convert to special unit. And it is usually, it's optional. So whatever desired unit it is, whether it be volume or molecules, you can always convert here. Okay? Okay. So let's do the first type of problem that we have is mass to mass conversion. And you often solve for a maximum amount of the product that can be obtained. That's usually what a mass to mass is. This is also called your theoretical because it's the maximum amount of the substance that can be obtained. It's the theoretical amount of the substance obtained. So let's do this example problem. Acetylene gas is produced by adding water to calcium carbide. Solve for the theoretical yield, which is also, remember, when we say theoretical yield, we're talking about grams, okay, of acetylene produced by adding water to 5 grams of calcium carbide. So we're going to start with our equation first because remember, the first step is always to write a balanced chemical equation. So we're going to start with the chemical. So 2H2O liquid plus calcium carbide. And it's going to produce acetylene, which is a gas, plus calcium hydroxide, okay, which is also in this case a gas. So in this equation, we start off with 5 grams of calcium carbide. That's given to us. So 5 grams. and we are looking for how much of the acetylene gas is produced. Okay, so we're going to start off with what's given to us. And 64.1 grams. And of course, you're trying to find the atomic mass, so don't forget the atomic mass of it. And then that is equal to 1 mole because it is grams per mole, the atomic mass always. And in this problem, notice that their coefficient right here is 1 for the calcium carbide, and the coefficient for acetylene is also 1. So it is actually a 1-to-1 mole ratio. And since we are looking for grams, which is the theoretical yield for acetylene, we're going to find the molar mass for acetylene. Okay, and that is and when you plug all this together in your calculator, you get this is what you get right here. Notice that we started our problem off with 5.00. That is 3 significant figures, so our answer is going to have 3 significant figures. It is 2.03 grams of acetylene. Okay, so that's our answer. And for molar mass, you guys, you can find the molar mass using your periodic table. So when you're finding it, you're looking at calcium and carbon and hydrogen. So you would be using your periodic table for that. Okay. The next one, you can do it on your own, and then you can look up as soon as you're done. Okay. But you can solve for the amount of the reactant given the yield of the product. Okay, so the next one is carbon monoxide undergoes combustion to produce carbon dioxide. If the experiment produces 15 grams of carbon dioxide, what mass of CO2 was reacted? And it would be 2 CO. In this case, if you're looking at it, carbon monoxide, carbon monoxide and carbon dioxide, notice what the coefficient is. So the coefficient is 2 to 2. Don't reduce it. Okay, keep it the exact same. Don't reduce it. So you're going to use that 2. Okay, so your answer is really 9.55 grams. Notice that we started off with 3 significant figures. Our answer is also going to have 3 significant figures. Okay? All right then. Let's go on to the next one. This is just a bunch of practice problems that you have that I'm going to go ahead and work with you guys on this for these practice problems, okay? So 5.50 gram sample of calcium carbonate is strongly heated. how many moles of carbon dioxide is produced. So you are more than welcome to follow along, or you can just work on this and then look up and check your answer. Okay? So notice over here for the first one, you guys, you get you start off with 5.50 of calcium carbonate, and you are looking for how much carbon dioxide is in there. Start off with what is given to you. Use atomic mass to convert to moles of calcium carbonate, and then you are once again going to look for your use the mole to mole ratio to convert from calcium carbonate to carbon dioxide. So it's a 1-to-1 mole ratio, convert. 1 mole of calcium carbonate will go on the bottom because you want to cancel calcium carbonate, and 1 mole of carbon dioxide, your new substance, will go on top. And then when you plug and play into your calculator, you're dealing with 3 significant figures, and your answer should have 3 significant figures. Okay? Next one is 1.22 moles of bromine is added to a solution of lithium iodide. What mass? This is what's given to you. What mass of iodine is produced? So that's what you're trying to find. Okay? So we're going to write our equation. That is the number one thing you do. Okay? So you can certainly do the problem on your own and then look up once you are done. You guys, don't forget to write the states of matter also. So use your solubility chart and look up the states of matter for all of these compounds. Okay? And use your state of matter periodic table also. Okay, this problem's a little different because you start off with moles of what you're given, and you are trying to find the mass of your new substance, which is iodine. So in this case, you guys, you're going to start off with 1.55 moles of bromine, and since it's in moles of your given, you don't need to convert it to, you don't need to use atomic mass. We use this step to convert our given into moles. But our given is already in moles, so we're going to go straight to the next step, which is using the mole to mole ratio. The mole to mole ratio of bromine to iodine, which is right here. Okay, and that's 1-to-1. And then, of course, it is 1 mole of iodine to 253.8 grams of iodine. You're using the atomic mass of your new substance, which is iodine, to convert to grams. Plug and play into the calculator, 3 significant figures, 3 significant figures. You want to put a decimal here because that 0 does matter now. Okay, number 3 is how many moles of oxygen are required for the complete combustion of 4.45 moles of butane. So we're looking for moles of butane. It's 4.45 moles of butane. Moles of oxygen, sorry. Okay. Okay. So the answer for number 3 is 28.9 moles of oxygen. Notice how short this problem was because you're going from mole of one substance to the mole of the next substance. So you really need to just use the mole to mole ratio in here. Given that, number 4, given that 2.75 moles of hydrogen peroxide, this is what you're given, decomposes completely, what is the theoretical yield of water, okay, in grams? So this is what you're trying to find. Remember, the theoretical yield always means grams, okay? And this is really, if you're having trouble writing the chemical equations, you really want to go back in your notes and look at the chemical equation unit and familiarize yourself with all those different chemical reactions and know how to write that, okay? Okay. So you have 2.75 moles of water that's given to you, and you want to convert it into how many grams of water is produced. So you started off with 3 significant figures, and you're going to end up with 3 significant figures. Okay? And then number 5 is how many grams of potassium are required to displace 5.5 moles of hydrogen gas when you react potassium metal to water, and it is okay. So in this case, you're given 5.5 moles of hydrogen gas, which is right here. Okay, and you're asked to find how many grams of potassium are present. So even though you were given something in the product and you're asked to find something in the reactant, it doesn't make a difference. You're using mole to mole ratio. You can go any direction whenever you're doing stoichiometry. So in this case, you have 2-to-1 ratio, so 1 to 2 ratio. So you have 1 mole of hydrogen gas and 2 moles of potassium. And you're going to find the atomic mass of potassium to convert to grams of potassium. You started off with 3 significant figures, and your answer is going to be 3 significant figures. So it's 434 grams of potassium. All right, you guys, that's all that there is to stoichiometry today. Hope I helped you out. See you later.